Okay, so in this video, I'm going to teach you how to factor perfect squares. And a lot of these are going to be perfect square trinomials. So I want to remind us what a plus b squared is. That's really like saying a plus b times a plus b. So then I FOIL everything out. First term, a squared. Outer term, inner term, and then my last term. So now notice here we have two AB terms. Now with the minus, the same thing holds true. A minus b times a minus b. When I multiply the first terms together, the outer terms together, the inner terms together, and then my last terms together, again, we still have twice of those middle terms because, is that what I wanted to do? I wanted to highlight. The A times a B is the same thing as an A times a B. So I really have two middle terms happening there. Okay, so factoring perfect square trinomials. You need to know what this is. I use this terminology a lot. Factoring perfect square trinomials. So, if you notice that you have a perfect square in the first term, perfect square in the last term, what you want to check is is this middle term to A times B. Okay, so when I look at this x squared plus 8x plus 16, what I often do is I often write that as x squared and 16 is 4 squared. Now, is the middle term 2 times this x times the 4? I should say that should be a times symbol in there. It is, because 2 times 4 gets me 8. Okay, so you have to recognize if something is a perfect square trinomial. That's really important to success on these. Okay, determine whether the trinomial is a perfect square trinomial. Write yes or no. So, what I want you to do is write this first term. The first and last term have to be perfect squares, which in this case they are. And 9 is 3 squared. Now you have to check your middle term. Okay, same sign in the middle, 2. So 2a, well, what was a? A was this piece right here, 5x. Times b, what was b? B was the 3. So what you have to check is your middle term. Does this simplify to 30? Well, 2 times 5 is 10 times 3. That simplifies to be 30x. So yes, this is a perfect square trinomial. So what does that factor to? 5x, same sign in the middle, minus 3 squared. I take my a and I take my b. And again, remember, you can always FOIL it out to make sure you factored correctly. Okay, for this next one, 49. Well, that's 7y squared. 36. Well, that is 6 squared. Now, my middle term is plus 2a times b. Well, a in this case was 7y. B in this case is 6. So I have, you want to look at 2 times 7 times 6. Well, what's 2 times 7 times 6? 2 times 7 is 14. 14 times 6 That's 84. That's not the same thing as what we have here. What they forgot to do in this problem is they forgot to multiply by the 2. So this is not a perfect square trinomial. Okay, so steps to factoring. First, factor out any GCF that you have. Okay, that's your first step. Then what you do is you check for a difference of squares or a perfect square trinomial. That's the next thing you check. And then if it's a trinomial, you use your factors or your 5-step method. Our book does a different method. Okay, when they're factoring the ax squared plus bx plus c, I find the 5-step method. It's basically a version of the 5-step method. I prefer the 5-step method. I think that it works better. Okay, so factor that trinomial. So I notice it's a trinomial, but I also notice something else. I notice the first term is a perfect square. I notice the last term is a perfect square. Now I have to check. Is that 30? 2 times a times b. Well, a in this case is 5x. B in this case is 3. Well, 2 times 5 is 10 times 3 is 30. I feel like that's very similar to the one that we did. So I end up with 5x plus 3 squared. So this was a perfect square trinomial. Okay, this one. Ooh, this one's hard. Okay, so first we always look for a GCF. So I need to see, what I see right away is I see 3 goes into each one of those. So I'm going to factor out a 3. And then we get that. So now I notice right away, 3 comes with it. (16n squared). Well, that's a perfect square of 4n squared. 25. Well, that is 5 squared. So I need to determine that 40n. Is that 2 times a times b? A we said was 4n. B we said was 5. So 2 times 4 is 8 times 5. Hey, that's 40. I just noticed a little minor mistake in here. That should be a plus sign. So this is a perfect square trinomial. So this factors to something squared, same sign in the middle, for n and 5. Okay, factoring this trinomial. We actually did something like this in the other video. I just added this in because it was in our textbook. So this, first you have to look for a GCF. So I factor out a 3 because a 3 is in both terms. Now this is a difference of 2 squares. So since 4 is a perfect square, remember when we factor a difference of 2 squares, it's the same number. K is the same thing. 2 is the same thing, just you have opposite signs. Okay, factoring this trinomial. I'm looking at it. I don't see, looks like 3 doesn't go into anything. 3 goes into 15, 3 and 5, but 3 and 5 both don't go into the other ones. Okay, the first term's a perfect square, but 15 isn't. So, looks like we have to do 5-step method. I take the 16, I multiply it to the 15. Ooh, I didn't do this one ahead of time. So I have 16 times 15. So now I start looking at factors of 240. So 240. I'm going to have to keep guessing here. Apologize. So I've checked 2, I've checked 3, I've checked 4. One has to be positive, one has to be negative. Oh, I should have done this one ahead of time. So this is quite honestly, this is the problem with the 5-step method. All right, I'm going to pause my video here real quick. It's the one I didn't check. Okay, so I paused my video and I went through and I just started trying different factors in my calculator. And the ones that I came up with are 20 and 12. Because 20 times 12 is 240. 20 has to be the bigger one since 8 is positive. Now I go through and remember to divide. 20 divided by 16, 4 goes into both. 12 over 16, 4 goes into both. And then remember, any denominator swings up. And becomes a coefficient. So that was actually a pretty complicated 5-step method. Question. Okay, solve this equation by factoring. So remember, you want to get one side to be 0. And you always want your squared term to be positive. Okay, I see right away that this is a potential perfect square trinomial. So the square root of the first term is 2x. Then I would have plus 2ab plus the last term squared. B was 9. A is 2x. So now we need to look and see. What's 2 times 2 times 9? Hey, that's 36. It's still equal to 0. And so this is a perfect square trinomial. So 2x plus 9, meaning each one of these factors, since there is 2 of them, should be equal to 0. You get the same thing because it's the same factor twice. Okay, square root property. When we solve a quadratic equation where x squared equals some number, we take the square root of both sides. And then remember that when you have square rooting both sides, you have to remember the plus and minus. Okay, so the equation x squared equals 25, we square root both sides, and it's the square root of 25 plus or minus, so that's why we get plus or minus 5. Because 5 squared is 25 and negative 5 squared is also 25. Okay, so this one. Square root both sides. So when I square root both sides, I get b minus 7, because the squared and the square root, they kind of like cancel each other out. Square root of 36 is plus or minus 6. So we really get b minus 7 equals 6, and b minus 7 equals negative 6. Set up the two equations. Add 7 to both sides. Add 7 to both sides. I had the correct answer. I was thinking about it in my head, just couldn't write it. Now it says to check my solution. So I plug in 13 minus 7 squared. Well, that's 6 squared. That's 36. 1 minus 7 squared. Well, that's negative 6 squared. Negative 6 times negative 6. That is a positive 36. Okay, now this one. We square root both sides. Square rooting undoes that squared. So I have x plus 9 equals plus or minus root 8. Now root 8, doing a little side work, we want that in simplest radical form. Root 8 can break up into 4 times 2, since 4 is a perfect square. Square root of 4 is 2. The plus and minus goes to the left, so this is plus or minus 2 root 2. So then I subtract 9, and the 9 goes in front. So it's negative 9 plus or minus 2 root 2. And then you could actually, it's actually not a bad checking. I'm going to power through checking. I'm going to check it in green. So if I plug in for x, negative 9 plus 2 root 2 squared. Oh, I forgot to add in. So that was just my x. I forgot to add in the plus 9 squared. That 9 and that 9 cancel. So I have 2 root 2 squared. Well, that's 2 squared. Root 2 squared. So that's 4 times 2. That equals 8. So that works. Something I also want to kind of highlight is you really have two answers here. You have negative 9 plus 2 root 2, and then you have negative 9 minus 2 root 2. Now, if I were to plug in negative 9 minus 2 root 2, let's do that. Let's do it in this pink color that I like. I would have negative 9 minus 2 root 2 plus 9 squared. Those 9s cancel, so now I have negative 2 root 2 squared. So I have negative 2 squared times by root 2 squared. Well, that turns into 4 times 2. And again, that's 8. So we could check our solutions. And I always want our answers in simplest radical form. Either one of these two forms is acceptable. I just need you guys to make sure you realize that this really means there is two solutions. Okay, so that is my video on perfect square trinomials.